Hi, everybody. Good evening. Welcome to the virtual night sky, our version of the program for June the 15th, and racing ahead. Welcome to summer almost. Things are getting hot enough. It sort of feels like summer. Things are really slow around campus, although we are doing a lot of camps right now. So that just is one of those things we do in the summertime. Kids are doing camps all over the place, and they have their little summer programs, and then we become a resource for them. So they come visit us. My name is Rick Alling, and I am the manager of community outreach for the School of Earth and Space Exploration, and especially the visitation of the facilities that we call home. ISTB4 is our building. The Marston Exploration Theater is part of our program, as is a gallery of scientific exploration. And so those are open during the summer, and so I do want to sort of encourage people to look that up. And if you'd like to come by for a visit, we are fully air conditioned, and there's a lot to see. You can visit with us and chat with us a little bit along the way. If you actually have kids in camp, or if you sort of have kids on their way to camp or something like that, and those camp counselors are looking for something to do, you might mention that we also have programs for people this summer as well. I'm not alone here doing the virtual night skies. There's a whole team behind us, and so I want to acknowledge that Kim Batista is here. Kim is your webmaster, and she's the one that sends out the communication, gets these things going, keeps us all organized, and keeps us rehearsed and ready to go. So thank you, Kim, for that. Meg Hufford, as always, my colleague and co-worker for the past 12, 15 years at School of Earth and Space Exploration. She's with us tonight too, kind of helping move things along. Alicia Hyatt is one of our new employees. She's an education specialist, and she's with us tonight. And two students, Alex Blanche, you guys know Alex, and Armand, three students. Armand is with us again tonight. And we also have a guest student, Malhar. I'll introduce him a little bit more formally in a little bit, and he's going to sort of join us for a little bit and tell us a little bit about the upcoming solstice. So with that, we've actually got quite a little program. We're going to deal with the lineup of planets that is in the morning skies. It's about the last time we will do this. It's been going on for a while, but it just happens to be special again this week and next. And so we'll be kind of just giving you what to watch for, and we'll just kind of review how we observe those planets and what kind of characteristics they have just by virtue of when they appear in the sky and their movement, their orbits, and how that sort of makes for how we get to observe them in the sky. And we also are going to give you just a poke around a little bit, some things to observe in the night sky in the evening. So you don't have to get up at 4:30 in the morning, although I'm going to encourage you to do that. But we also have some evening things going on. And there's some announcements and some updates. A really cool new mission we'll just sort of give you a little tantalizing introduction to. And that's how we're going to deal with our program. If you're new to us, welcome. We always advise people just kind of like make this full screen. We'll do the pinning, and we'll try to do the production in the background. We do closed captioning, but you're kind of in charge of that on your own. If you want it, you have the controls. You can leave it on your screen. If you don't want it, you can turn it off. And we also encourage everybody to use the question and answer button, maybe even for more than questions and answers. So if you want to, we don't allow chat. That doesn't happen in this particular version of the web, the web Zoom stream that we have. But we do encourage you to just, ask, do questions along the way. Anything you think of, anything you want to sort of like address. And how that works is that there's a team, those students, those people working in the background are following that all the way through the program. And they'll just knock off questions that they can answer real quickly. And then they also organize to bring some forward so that we can actually have, people, we can do those questions live as well. But that's our tool for hearing from you and what you're thinking about the program and any questions you might have about what we're talking about. That's how that works. And so I really appreciate it if you would do that with us and for us, is take liberal advantage of the question and answer button on your screen. Just in the way of getting started, I just have to wake up a machine over here. Just 1 second. That always happens to me. I get all set up, and in the 10 minutes, we're listening to Jack Johnson. The screen kind of goes dead. I think we've got it here. what I want to do is kind of just show you a little bit about planets and how they're in the night sky. And in order to do that, I'm going to use a very special program. It's called DS2. You've seen me use this before, I think, in programming. And essentially, what this is it's a database program, and it has included in it all of the planets, all of the moons of the planets and the solar system base, plus a lot of data about solar system things. It includes also nearby stars, stars of our galaxy, all kinds of galaxy sets, and it is the tool we use in the Marston Exploration Theater to show people around the night sky. I am going to back way out, just get kind of out to a view of our solar system. I see some planets and a little sun coming into view here. Let me center the sun. I'm just going to kind of add the orbits because I want to just remind everybody, what this is, why we call it a system, what the solar system actually is. We sort of get hung up, I think, sometimes on the individual planets, but you can think of the thing as a system in and of itself. There is a sun in the middle of this system, and there are 8 major planets. There are also minor planets. There are also asteroids and comets, and there's all Kuiper Belt objects. There's all kinds of things happening in our solar system. But the main thing is that sun and 8 major planets. In fact, if you took an inventory, if you just took everything and divided it into its little categories, major little stacks of planets over here, and comets over here, and asteroids over there, what you would find is that the vast majority of the mass of the solar system is essentially represented by those orbits of planets you see on the screen right now. It's like 99.4% of everything is the sun and the 8 major planets. There is a whole bunch of other stuff going on, but today we're going to focus on the planets themselves. And we're going to also sort of like get you set up to sort of know what to look for, what's going to happen over the next couple of weeks in the morning sky. And unfortunately, with the solstice, with the summer hours, sunrise is really early, so you got to get up at about 4 or 4:15 to actually see some of the stuff we're going to deal with today. All right, just in a way of explanation, I'm going to play some tricks with the solar system here. So first, I'll do this. I'm going to size up the planets. Right? I'm going to make them bigger than they really are because that's going to be part of our explanation. So I just don't want you to sort of think that planets are actually really this big. They're not. I have these tools and I can size them up. And the other thing, sometimes the sun's glare gets uncomfortable in the field of view here. So I get to sort of like just kind of, so here's a glary sun. I just get to turn it down a little bit. And so that's how we're going to start to visit our night sky and these planets. So let me just back up a little bit. We're going to get a whole view of everything. I'll turn those orbits back on so you can see what that looks like. And I'm also going to show you some changes in time. So this is a real-time presentation, and that means that I'm just going to move everything right into order so that they're in position where they are tonight, right now. So if you were to fly in from outer space and look at all of our planets and where they are in the night sky, what you would see is they're in their locations, in their orbits, around the sun at this particular location right now. And I'm going to back way out so you can sort of start to see a little bit of stuff here. Let me see, I'm going to just do one quick thing. I'm going to do a little size up here. So I think you can see out in the outer edges here, there is the orbits of Uranus and Neptune are out here. We don't want to forget about those planets because they're also large and in charge and in our particular view. I'm going to do another little thing here. I'm going to fly back into the middle and show you a little view of the Earth and the Sun relationship here. The thing to sort of see here real quick, I'm going to get a little bit, I'm going to make a little adjustment this way, and I'm going to line up the Earth and the Sun together. There's your Earth. There's your sun. And what we've got going here is if you draw a line basically from the Earth through the sun out into space, just sort of everything on the right side of that line, everything on the right side of the screen is going to be planets and objects that are seen in the morning sky. Everything on the left side of the screen, from that sort of like line, Earth through the sun, extending out into space, everything on the left side of the screen are objects that you're going to see in the evening sky. It just so happens is that everything in our solar system right now happens to be objects that are over towards the right. And you can sort of start to see as I just move around, I'm just kind of jostling around just so you can get a little picture of what's going on. You see the sun in the middle, Mercury, Venus, Earth, Mars. Way out there in the distance behind the sun is Uranus. There's Jupiter. Neptune is out beyond Jupiter, sort of in that particular line. And then way over here is Saturn. All of these objects are in line and in space above the eastern horizon, just a little bit before sunrise. And so I'll sort of like leave you with that particular image. Okay, before we go there, I am now going to go I'm going to go forward to 4:15 tomorrow morning, because that's a good time. I'm just setting up my little clock here. Here we go. And I'll just do that in about 5 seconds. So you see the Earth is spinning. There's our United States, our continent right there. If I move in just a little bit, let me just sort of get us a little bit closer. And I'm going to move over here so that I can put the Earth just barely in front of the sun. And so, and then in a moment here, as soon as I get it set, I'm going to get it set just right there. So here's the scene tomorrow morning at 4:15. Here's Phoenix right here. There's Tucson. Here's sort of the LA basin, San Francisco up here. Phoenix again. Here's the horizon. You see the atmosphere there. The sun is just below the horizon. And now I'm going to play a little sort of a trick. This is a little bit hard to do, but I'm going to just kind of sort of move us out in a direction so that we can see the planet. So as I kind of go out in this direction, I want you to say these with me as we go out. So Mercury is the closest to the sun, and then Venus, and then Uranus is in the background, and then Mars comes into view, and then Jupiter comes into view. And this is really the true locations of where these objects are. See Neptune way in the background out there. And then if I get a little bit farther, we see Saturn. All of these planets, just as I sort of described them here, and as we're sort of like panning back and forth across this scene, are going to be in this order in the sky in the morning. And some of you have probably been watching this happen over the last little bit. And if you have been for the last couple of months, there's been a nice little show here, some nice little conjunctions every once in a while. And I've just let my son get out of the way. I'm just going to come back again. And then I wanted to spend a little time just introducing you to each planet individually for a moment, and how it interacts with us and how its orbit impacts the way that we see them. So I am going to start with Mercury. I'm just going to isolate Mercury on the screen along with the Earth. And I'm going to go forward in time a little bit so you can start to see how they move in space. Here we go. Somehow in this arrangement, I have actually sort of like ended up upside down. So I'm going to flip them around a little bit and get them back sort of so they're right side up. Anyway, so this is really the Earth-Mercury-Sun relationship. And I'll just stop here for a second and show you that we actually sort of view Mercury as it sort of pokes out on one side of the sun, and then it sort of dives in between us. and the sun, and then it kind of goes out the other side. So I think you can sort of see from this little diagram, when it's over here, it pops out and it's an evening object. It never really gets very far away from the sun. It's only out here for like about 2 weeks that you can actually see it. And then after that 2 weeks, it dives in between us and the sun, and then it will pop out the other side. Just kind of go out this direction for a little tiny bit, and you'll see it for another 2 weeks and then around. And so the whole process is on a little less or a little more, 4 months, give or take. That's because Mercury has a really fast orbit. It it orbits the sun in about 88 days, and so that's kind of how we get to know it. And I like that because Mercury is the messenger. He's a little fleet of foot. He's got little wings. He flies around. He dives in behind the sun. He comes out. He goes around. You sort of think about nymphs or sprites in the forest, ducking in behind trees and coming out again. Venus, on the other hand, this is the next one on the stage here, has the same characteristics because it shows on one side of the sun and then moves around and then shows on the other. But its orbit is actually much longer than Mercury's. It's about 223 days. And so it still plays that game where it comes out and sort of like makes itself appear in the western sky for a period of time. Then it kind of goes in between us. And then in this particular simulation, given a little bit of time, it'll come out on the right side of the sun, and it'll be a morning object. When it is in the sky, unlike Mercury, which does its little appearances for about 3 weeks, Venus is up there for about 8.5 months. I mean, once it appears in the sky, again, it is limited to how fast or how far it can go from the sun. Its greatest elongation is about what this characteristic would be right here. You see this distance between the sun and here. It's about 45 degrees of angle, and Venus cannot get any further away than that. So it becomes a morning object. It gets fairly high above the horizon. You see it for about 8 months, and then it'll dive back into the sun. Then in a little while, it'll become an evening object and do exactly the same thing. So those are the two inner planets, and that's kind of the characteristics. I like the way that just by virtue of their orbits, by virtue of the speed of those orbits, how fast they operate. I'm going to just show you a little bit about an Earth-Mars relationship now. Very different, because our Mars orbits around us. And so in this particular case, right, we move faster than Mars. It's chugging away in its orbit. We're chugging away in our orbit. And for periods of time, we sort of get opposite each other and the sun, and we're very far away from Mars in this particular scene right here. That's where that is. You can see that. But again, we're moving faster. So now Mars is a morning object for us. We're moving in this particular direction. We're actually going to catch up with it and lap it. And then we will have a very close approach. This particular close, it's called a superior conjunction. This happens about every 2 years and about 3 or 4 weeks. And so I say about like this because where they are in their orbit kind of depends on how fast they move and all of that. So, but approximately a little over every 2 years, the Earth and the Mars come together in their orbits. And it shouldn't be a surprise to you that actually when we launch Mars missions in this particular simulation, we would launch about now and send a spacecraft into space. It would follow the Earth's orbit and just sort of can move its way out in an orbit towards Mars. And then when we're a little bit beyond that particular conjunction time, the spacecraft will sort of like arrive at Mars. So we do those about every 2 years. In the last cycle, about 2 years ago, that's when Perseverance rover left for Mars and then landed some months after that, and has been driving around ever since. There aren't any big major, I haven't seen any big major efforts to get to Mars in this particular cycle, the one that's coming up. But that doesn't mean that the next one there will be. I think we're getting ready for that one where we're going to be doing a sample return from Mars, and that will either come up in 2 years or 4 years, depending on how fast we can get that ready. So Mars and its orbit are kind of interesting. Also, as we pass Mars, we do this from our perspective, from our point of view. It looks like Mars is going backwards in the sky. You've heard of this before. It's called retrograde motion. So where Mercury is real fast, darting around, going behind the sun, reappearing, Venus is far more bright, far more beautiful, far more sort of gracing the sky in the evening and the fall. It's sometimes called the evening or the morning star for that reason. Mars is actually a little bit weirder. It's a little bit reddish. It actually does that retrograde motion. Sometimes it's big and bright because we're close to it. Sometimes it's really far away and it's dim. And it has taken on the characteristic of as we know from Greek mythology, the god of war, a little bit more unpredictable. Just really quickly, I'm just going to kind of move out to Jupiter. Our relationship with Jupiter is a little bit different, further away. It's got about a 12-year orbit. And what that means is that approximately every 13 months, we come into, or 13 years, I'm sorry, no, I said that right the first time. About every 13 months, we come into conjunction with Jupiter. And I'll just move us really fast and sort of like see, and you can see it move around as well. And so as we do that, as we come into conjunction, Jupiter has moved just a little bit incrementally in its orbit, very slow. So it tends to move very slowly and very carefully between the signs of the zodiac as it moves through space. And then finally, I'm just going to add the orbit of Saturn because it's out here. Like Jupiter, Saturn has a really, really long orbit. It's a little bit less than 30 years, about 29 and a half years for it to go all the way around. And what we see sometimes is the relationship between Jupiter and Saturn, where they kind of come together. We can actually see from our perspective when they're sort of in alignment, but that happens very, very rarely. Today, I'll just sort of go back to now. This is the relationship between all three of those objects. There's the Earth in its orbit around the sun, Jupiter is there, and Saturn is out there. You might remember a little bit, almost a year and a half ago now, it was November of 2020, there was that thing called the Great Conjunction. And I can just sort of, let me just go back there real quick. And in that particular, I'm just going backwards in time now, and I'm going back to, I guess I'm in 2020 right now, and you will see sort of this, there was a period of time when we could look at Jupiter and Saturn, and they looked like they were right next to each other. Well, that's old news. That was 22 years ago, and that same condition will not happen for a long, long time. I think I was looking at it today. I think that doesn't happen until 2040. So there's a long sort of dry spell between us and when that particular happens. The point, I think, is that each one of these planets have their characteristics. They have their own sort of orbits and their own way of being. They present themselves to us in different ways. But now I'm going to kind of just do something a little bit weird. I'm going to kind of land us on the Earth. And I'm going to move us around so that we're sort of looking at that particular part of the sky. And I've left the planets enlarged. Let me just sort of restore those and put the halo of the sun back on. And I'm going to take off I'll just leave the planets at their size. And no, I'm going to do this a little bit differently. Sorry about that. I'm just going to kind of give you some labels so you can see where they are. And we'll just sort of like move backwards and forwards just a little bit. So the sun is bright in the sky right now. If I go backwards a little bit, you can see the sun descending below the horizon. And this is what that scene looks like in the morning. So remember, in order, the planets that we could see are Mercury and Venus. And we could see Uranus way, way out there in the distance. And then next in line was Mars. And next in line was Jupiter. I'm sorry, Neptune. And then Jupiter. And And then Saturn is off in the distance. So if I sort of move this ahead a little bit, you'll see all of these objects in space. Can move up and then let the sun rise. Let me just sort of like put in some cardinal directions here. And so you'll see there's east in our particular horizon. And when the sun is just below the horizon, you can see all these objects in the sky. You know what? I actually went too far ahead. I am going back a little bit. Sorry about that. I got carried away and I went too far ahead. And so as the sun comes up in the eastern horizon, these planets are sort of in the sky, and then as the sun gets brighter and brighter and brighter, everything will start to disappear and fade. And this is really the scene that's going on in the morning sky for the next several weeks. And so I'm going to encourage everybody, if you want, I've set this up for tomorrow, but I'm also going to talk to you a little bit in the next segment. I'm going to actually we're going to talk a little bit about the solstice. And when I come back, I'm going to talk about what's happening when you're going to see the summer solstice and what will be happening in your morning sky. So, so I hope that's a enjoyable little look at the planets. How they act in space, why this is sort of an interesting moment that they all end up in this particular location. To me, it sort of looks like they've gotten together for a little crowd shot. They're showing us, they're presenting themselves to us in a very, very special way. And I always look forward to those kinds of things and try to get an audience to go out and just kind of check it out. You're not going to see things exactly like this ever again. And so this is really one of those really wonderful phenomena that you can go out and look at yourself. All right, I am going to take a little break, rest myself. I'll be back in a couple of minutes. But in the meantime, I want to introduce you to a new student that we have. He's actually been with us with our program for about, I guess, 8 or 9 months. Malhar, maybe you can help me with that number. I think that's what it is. This summer, he's working on a real kind of some special projects, just in coding and organizing some of our files and some of our programs and some of our shows that tie into classroom work. And it's a good summer project for us to do. But Malhar today is going to join us. He's put together a little program about the coming summer solstice and how it is meaningful essentially to cultures across the world and throughout history. Malhar, why don't you join me on the screen?
Yeah, hi. Hello, everyone.
How you doing?
Yeah. Good, yes. That was a nice presentation.
Thank you. I'm going to let you go. I'm just going to kind of fade my screen so you can kind of take off.
Okay, yes. So, hello, guys. Hello, everyone. And we will now talk a little bit about the upcoming event, that is the summer solstice. So, summer solstice is going to happen on June 21st. So let's get to the next slide. And so solstice, basically it's its origin is from a Latin word called as sol. It's a mixture of sol and sister, that is sun standing still. So now why the standstill motion? We'll get to it in the next slide. Summer solstice is basically the longest day in the year, and it marks the starting of summer season. In the northern hemisphere, we observe the summer solstice on June 21st, whereas in the southern hemisphere it's observed on December 21st, and which is a winter solstice in the northern hemisphere. So the reason why it's summer on one pole and winter on the other is represented on the image on your left. Because of the Earth's tilt, it's looking towards the sun, like the northern hemisphere is looking towards the sun during June 21st. And that's why the Arctic Circle experiences 24 hours of daylight, whereas the Antarctic Circle experiences 0 hours of daylight. And the opposite happens during a winter solstice. Now, summer solstice, it dates back to way back to our ancestors and how they used to use it to get an idea of when to start their harvesting and when to start farming. It also holds few religious importance values in many cultures. So as we go to our next slide, here you can see something called as the sun's analemma. So on your right bottom, the image that you're seeing is clicked from Arizona. And now an analemma is basically a picture or a diagram of position of sun throughout the year taken from a fixed position at Earth at the same time or at the same mean solar time. And when you click pictures of sun at the same time from the same location throughout the year, you'll get a picture that is a diagram that represents a stretched 8 or stretched infinity symbol, which is slightly unsymmetric. Now, the reason that this happens is because Earth's orbit is not exactly circle. It has a slight eccentricity. And because of the eccentricity, the annulema, the width of the annulema, it represents the Earth's eccentricity, whereas the length of the annulema, it represents Earth's tilt, Earth's tilt, that is 23.5 degrees. Now, on the right bottom image, point A represents position of sun during the summer solstice and point B during the winter solstice, as seen from northern hemisphere. Now you can see those small curves has a high density of sun's position over there, and this is the reason why we call it a standstill position, because the apparent position is not moving way too much as compared to the other segments of the annulema. And in the next slide, now you can see an image of the Stonehenge. Now this is quite a famous image of Stonehenge, and you must have heard about Stonehenge, the location, and what archaeological importance it holds. Now, during June 21st, many people gather around Stonehenge in United Kingdom, and they observe sun rising exactly through the center of the tall vertical rocks over there, and the sunrise is aligned with the central axis of the Stonehenge. It's basically a circular structure with an rectangle in front of it. In the next slide, you'll get a good idea of when we see the top view. So the sun rises exactly from the center, and it's a beautiful view. So many people gather around during June 21st at Stonehenge. In Egypt, so during June 21st in Egypt, in the night sky, you can see the rise of Sirius. And this is the time when Nile River floods, and it enriches the basin that's around Nile River. So that marks the start of agriculture season, and that is why it's also an important time of the year for Egyptians. In the European and in the North European and most of the Scandinavian countries, they celebrate the solstice by making bonfires, and everyone celebrates that the harsh winter has ended and a warm summer is going to start. So it marks as a time that good time and prosperous times are going to start. Norway has this competition where you have to build the tallest bonfire, and it holds the world record of a bonfire as high as 510.5 feet. That is almost 155 meters tall. It was done in the year 2016. And Russia also celebrates in a similar manner, but in modern times, the kids, they start playing with water and they celebrate that the harsh winter has ended. In the next slide, and this is the top view of Stonehenge in UK. And as I mentioned, the heel stone you can see over there. So the sun rises exactly on the right side of the heel stone, and it aligns with the central axis of the Stonehenge structure. And on the bottom, it's a diagram of the Chaco Canyon in New Mexico. So in the Chaco Canyon, there's a stone which has petroglyphs. Now, petroglyphs are something that were created by the ancient people. They're basically carvings on stones, and they represent different pictures and structures and different stories. Now, one of the petroglyphs that is called as the Sun Dagger, it's basically a spiral, and in front of the spiral, there are vertical rocks over there. So during summer solstice, what happens is the sunlight passes exactly through a central gap of the vertical rocks, and it cuts the petroglyph structure into two halves. And during equinox, we can see that there are two patches of sunlight which frames along the petroglyphs, and that's how they used to know what time of the year it is. And it's sort of a sundial that they used to use it. In the next slide, so these are some modern time celebrations that happen around the world. The top image represents the Alps mountain range with bonfire at different places, and it's a beautiful nighttime view. In the bottom images from your left, you can see that there are garland structures. Now this image is from Sweden. So they make garlands, and they celebrate the happy times that are going to come during the year. The next image is of the Stonehenge with all people gathered around Stonehenge for observing the sunrise during solstice. And on the right side, that is the tallest bonfire that was created in Norway. So yes, these are some ancient ancient stories that are related to solstice and some modern time celebrations that we observe. So hope you guys also enjoy June 21st summer solstice and go out and watch the sunrise on the longest day of the year. Thank you.
Excellent. Thank you, Maher. Thank you very, very much. I love the sort of see how people have used astronomical phenomena throughout culture, and it still does. I mean, the big celebration at Stonehenge is something people do, like it's a big, huge deal. So, so these are things that still go on. We don't really celebrate the summer solstice much here in the United States. I think a lot of us are aware of it. We sort of talk about it on the news, and we sort of talk about it as being the longest day, but it really has had a tremendous amount of influence and understanding cycles, as Maher has pointed out over time. We're going to take a little bit of a break now. Thank you very, very much, Maher, for putting that presentation together. We're going to just take a little break, and I'll ask if there's any questions that need to be brought forward to the group. And also, we have some poll questions, something for the audience to participate in. So let's check this out. I think Alicia is running our poll questions for us.
Yes, thank you so much, Rick, and thank you, Malhar, for that wonderful presentation. I'm going to go ahead and launch our polls now. There are two questions. Our first, what is the meaning of the solstice? And our second, are you planning on watching the rare 5-planet alignment on June 24th? So go ahead and cast your votes below, and I will turn it over to Alex to see if there are any questions that we can answer.
Thanks, Alicia. We've had a lot of good questions that have been answered in the chat. A lot of questions about ellipses and orbits, which are great, but we don't have any that we can answer live at the moment. So just keep putting them in the Q&A box, and we'll mark them for live answering or answer them in the background.
Sure. We probably should have time to take another little break before the end of the program, but thanks for staying ahead of the questions. I'm looking for that. I appreciate that. So.
Well, then we can check back in on our poll. And once we finish that, again, don't forget to ask questions to our Q&A. But the first, what is the meaning of the solstice? It looks like 84% or 100% of us got that right. So that's awesome. 86 people. So the time or date twice a year at which the sun reaches its maximum or minimum declination. So great job.
Declination is a big word. That's a good one. Right.
I know. I thought we'd confuse them, but nope. And then our second question, are you planning on watching the rare 5-planet alignment on June 24th? 84% of us said yes. So that's super exciting, Rick.
I will be able to give you something to look for. I'm going to use a different program. We'll go over that again. So, all right. Hey, I appreciate it. That's really super cool. Thank you. All right, I've got another little chart here to use to sort of show you guys some stuff going on. You've seen this before. If those of you that have seen the show before, I'm kind of a chart guy, and I like to draw, and I like to sort of like use things to like this to illustrate problems. And I've got a little sort of pen and a program here where I can do this. But first of all, the big picture here. This is essentially the night sky above and below your equator. So it doesn't include the poles, like where the Big Dipper and Little Dipper are, and it doesn't include the southern part of the sky, the part we can't see anyway from the United States. So the line that goes right and left, right across the center, I guess I could just sort of like draw a little line across here. That's actually your equator. And it's also your equator, the equator of the Earth projected out into space. So things that are in the sky, like the stars that are in the sky above that line, right, are kind of towards the northern part of our sky. They're above our equator also, and the things below are sort of in the southern part of the sky. That sort of makes some sense. But the big star of the show tonight is that line that sort of like is like a sine wave, the one that starts at the right side of the screen, goes down a little bit, and then up, crosses the equator, goes up a little bit, and then down. And that's what we call the line of the ecliptic. And so I guess guess that question has come up a little bit in sort of the question and answer. So when we were looking at the solar system, and especially the flatness of the solar system, how all of those orbits sort of like stack against each other and cause the solar system look like a plane, that's kind of the reason that we have an ecliptic, is because all of the planets are sort of on the same plane, if you want. What we look like at in the sky, though, is a result of the tilt of the Earth. So the sun basically starts over here this is going to be the fall equinox over on this particular side. And then this will be the winter solstice over here. This will be the spring equinox over here. And then the summer solstice is going to happen over here. So you can see that the sun gets lower in relation to our equator, right? In the wintertime, that's this particular area over here. The sun gets higher related to our equator in the middle of summer, and that's the June 21st, and that's the solstice, and that's kind of where we go. Let me just sort of show you a little bit more about this. I'm going to zoom in really, really big here. First of all, you might recognize the names of some constellations. I think I'm just going to erase some of the stuff I put on the screen. You'll see Taurus here, Gemini here. And if I go backwards, Aries is down here. And if I go forward a little bit over this way, you see Cancer. Those are all constellations you might recognize are constellations of the zodiac. And so those all 12 of the zodiac signs are sort of like traced by this line of the ecliptic. And if you can see really closely here, there are dates written against the line. See how this one says June 10th right here? That means we can actually place the sun today. This is 11, 12, 13, 14, 15. So essentially the sun is along that line right here today. It's almost achieved its greatest height, right? And in about 6 days, right, it will be right here. It's going to be at that highest point. It reaches what we call the Tropic of Cancer on the Earth. It's sort of like it's as high as it goes. And that's the beginning of summer. And then it will start a journey back down. But notice how level this line is. When Malhar was talking about the name of solstice, right, what that means is that the sun appears to stand still for a little while. So if you observe this against a horizon, it will achieve this sort of like highest arc right here. And on the horizon, it'll achieve its most northern point, right, either east or west, depending on which way you're looking. And it'll just kind of hover there for a while. You really can't tell the difference of the sunrise for 3 or 4 or 5 days either side of the solstice. It just sort of says it. And that's really where that term standstill comes from. So this line then is the ecliptic. It is the ecliptic as written across your star chart. It is also the path of the sun through the sky, and it is also the path of the sun as it sort of moves from constellation to constellation during its journey from top to bottom. One more thing I want to show you, because I'm going to get to a night sky thing. I've got some stuff for you to look at. If I were to just sort of like sketch in a line that looks like this right across here, sort of that right here, you could call that your western horizon. And so I'm going to show you on another star chart, we're going to look for these 4 stars. Capella is right there at the top, Procyon down at the bottom, and then the twins, Castor and Pollux, which are the twins in Gemini. You see how they're sort of laid out there? Castor and Pollux are going to be just sort of straight up over the horizon. Procyon will be closer to the horizon to the south. Capella will be closer to the horizon up in the north, and we'll just see if this sort of like works in a star chart. The same thing can be done the other way. So this time of year, the sun is right here in this particular part of the sky, and I can also draw a line kind of going this way. This will be your eastern horizon in the morning, right? And so this will be there. So these stars that are over here, like Rigel and like Aldebaran right here, these are sort of part of constellations. We've talked about those before. Those will start appearing in the sky, and they'll get higher and higher and higher every morning, right, before the sunrise. The ones that are over on the western side, those are actually sort of sinking into the sun, and they'll get harder and harder and harder to see as the sun moves through its location. So it all sort of makes sense. If the sun is moving in this direction, it is starting to obscure the stars that are kind of close to the western horizon, and it's revealing new stars in the eastern horizon. There's a term for this. We call it the heliacal rise and the heliacal set of stars. And so as Malhar was also mentioning about the star Sirius, when you can first start to see it in the morning, that's this star right here. That means it's essentially the sun is moving forward enough that so that Sirius is available, or you can see it in the morning sky. And that's sort of the term we call its heliacal rise. Let me just sort of show you a little bit about this stuff on this particular map. Remember the ones I asked you to look for right here. So this is actually the night sky tonight, right after the program. So you can see, if you can got a view of the outside, it's getting darker and darker. If you go out about 8 o'clock, right after the program, and go take a look, these are the twins. I have to use a white pencil, right? Or it's not going to work for me. Hang on a second. These are the twins right here, Castor and Pollux. And this is Capella. Remember, I said it was going to be nearer the horizon towards the north, and Procyon nearer to the horizon towards the south. So these stars, you'll be able to see them tonight in the night sky, and just kind of watch over the next week or so, because they'll get closer and closer and closer to the sunset, and you'll start to lose them. One more thing I wanted to show you, and then we're sort of going to move on to the morning, is this will be a little bit of a review, but you remember about a month ago, I'm going to set up the scene just right here for me. About a month ago, we did a nice little star chart talk, and I sort of pointed out that the Big Dipper is over here. It's going to be in the northern part of the sky, and it's very high in the sky. So this is sort of the thing that makes it different. And you can follow the arc of the handle in this direction to a star called Arcturus. It'll be the brightest star in your sky tonight. And you can continue down into this star right here called Spica. And so those will be available for you tonight. So you're looking for Castor and Pollux over here, Procyon and Capella up here, but also trace this out. Finally, right, while you're doing this, I want you to kind of look for this little constellation coming up right here. This is Scorpio. Scorpio is one of those constellations that really looks like what it is. It's sort of a scorpion. Right now, its tail will go down below the horizon, and there's his little stinger there. But these three stars and the red one, which is the heart of the scorpion, will start to appear. Spica is part of the constellation Virgo, and it sort of includes these stars over here. Next to Virgo is Libra, the scales, and next to the scales is the scorpion. And remember that line of the ecliptic, right? It keeps coming up. It's going to go trace through the sky exactly like this. So you're going to find all the morning planets along this line, and you're going to find these constellations that you'll start to see. I'm pointing these out to you because these stars in particular are really bright. They're easy to see in the sky. They're easy to sort of go find and look for. So in the west, you're looking for the twins. Over here, use my little sort of arc of the handle to Arcturus and Spica, find your way down to the ecliptic, and start to look for Scorpius, just kind of rising in the eastern sky. Last thing I'm going to leave you with here is I'm just going to move forward, if you don't mind. We're going to go forward to the morning, and this now should look a little bit familiar to you. Now, this is tomorrow morning. I'm looking towards the east. You can see that the sun is below the horizon here, and then there we go with that parade. Mercury and Venus and Uranus and Mars and Jupiter and Neptune and Saturn, just like we sort of saw them in space, just like we sort of now can look at them in the sky. But now let me introduce you to something new. I'm just going to move forward day to day today and watch the moon. So here is Friday, Saturday, it's right next to Saturn. Sunday, and Monday, it'll start to, Tuesday morning, it'll start to appear next to Jupiter. Wednesday morning, a week from today, it will be next to Mars. Then it'll sort of move down and pass Venus and Mercury, and then it'll sort of dive into the sun itself. Let's see. Alicia was asking you to look at the nights or this particular sky on the 24th. And that's when you're going to see everything in a really, really nice, perfect alignment. You can see my screen here shows I'm moving it ahead a little bit. Here's 4:15, something like that. I would not go out much after 4 o'clock and check this out. But here's the lineup. Mercury will be a little bit hard to see, but everything else is there. And if you watch over a little period of time, you'll also see that the moon actually also moves through the sky, just as the, sort of the days are moving as well. So there's a lot going on. You got stuff to look at in the evening. You got this amazing little parade of planets to look at in the morning. And I hope that's going to be something for you guys to take advantage of over the next weeks. And happy summer solstice to everybody. We're not quite done yet. I'm going to turn the microphone and the screen over to colleagues again. We've got a couple of sort of current events and some things that we wanted to chat with you about. And then I'll be back to close out the program just a little bit before 8 o'clock. Thanks, everybody.
All right, I'm going to kick things off with our current events.
Alicia?
Yes.
I like your haircut, Alicia, by the way.
Thank you, Rick. I got them all cut, but
Can I say that in front of everybody?
of course.
Nice, thank you.
Thank you. Let me see if I can get my share screen working here. All right, are you seeing the current event slide or are you seeing Psyche?
Just to share, it's still sort of trying to launch, but it hasn't launched yet, I'm afraid.
Says you started sharing.
It says you started sharing, but it never really came up.
1 second. That's interesting. Well, this week's current events are so top secret and so hot off the press. There we go.
There you go, I got it.
Awesome. Okay. All of that for nothing. All right, here we go. Current events this week. Recently, ASU announced a $35 million space mission involving, NASA announced a $35 million space mission involving Arizona State University. And it was is led by Carrie Donaldson Hanna of the University of Central Florida. It aims to land a spacecraft on part of the moon never visited before, the Gruhuysen domes. So very exciting. And ASU will provide a gamma ray and neutron spectrometer for the mission, which will be located on this rover. And this will be the first time this kind of instrument will make measurements from the lunar surface. So we're very excited. And the instrument will be critical in identifying the elemental composition of the surface, which is important to understand how these areas formed. So keep your eyes out in the next couple of months for more news on this mission coming up. But that's it from current events. I believe I'm going to pass it to Alex now to finish out our resources.
Yeah, thank you, Alicia. We're going to talk about the supermoon. The supermoon was just the other day, and probably a lot of people are wondering, well, what is a supermoon? It's not an eclipse. The moon doesn't change color. It's just a coincidence that happens when the moon's phase aligns with its orbit and its very particular point in orbit. So supermoon is basically just when you have the moon and it's full and it's close to the point in its orbit where it's closest to Earth. This is called perigee. This is a little bit more than 3,000 kilometers away from Earth, but this is just a point in time where the moon is really full, very bright, and then also closer than it usually is. Now, here on Earth, it doesn't really end up looking much larger. It only ends up looking maybe about 4% larger than it usually does on average. But compare that to when it has a full moon at its farthest point, it's about 14% bigger, 12 to 14% bigger. So it's a little bit bigger, a little bit noticeable, but not something that you might obviously see with your naked eye, but it's just an event that happens that kind of coincides every once in a while. And so, yeah, that was the supermoon that was just earlier this week. Yep, so that's kind of another resource.
And if I remember correctly, Alex, is also, I think, next in the July full moon is also supposed to be.
I believe so, Rick. Yeah, I remember hearing that. So we're lucky enough that the moon's orbit and its lunar cycle and its phases actually coincided for 2 supermoons in a row. So the next full moon will also be another supermoon as well. So yeah.
And I just can't remember, maybe 10, 20 years ago, nobody ever talked about a supermoon, you know. So to me, following the night sky for a long time, I think the term is kind of new. And it really doesn't, you know, you're right, 12 or 14%. I think it's noticeable, but
and that's it. It's maximum.
A super moon? I don't know.
Yeah, I would say it's a better than average moon.
Better than average.
I think they should change the term.
And there's really nothing like a big, huge full moon rising over the horizon. So
no, but you know, it was very, very full. You'll notice it was just almost a perfect disk in that night sky and near the horizon. It was very beautiful, I will admit. But yeah, you could get pretty close to that in any other full moon. But yeah, super moon. So, and maybe watch out for the one next month too. So yeah.
I love bigger than normal moon. I think that's really cool. Okay.
Yeah.
Sounds very good. All right, I am just going to kind of just give you a little bit of a preview of what we've got, maybe some ideas for the rest of the summer. One, in 2 weeks from tonight, when we come back, you guys might have remembered this. We've done this once before during our 2 years and 2 months of programming, and we're going to have a special guest. It's Lawrence Garvey. Lawrence is he's the curator for the Center for Meteorite Studies, the newly named Peter Busick Center for Meteorite Studies. And I don't know if you know this or not. You'll find out more about it in 2 weeks, but ASU has the largest university-based collection of meteorites in the country. And that has a long history. It started with a very, very large collection that was donated to us, and we've been adding to it and curating it and developing the collection ever since. At ASU, in the building that we operate in, there's not only a little visitor space, a place where you can sort of visit the meteorites, some of them yourself, but also in the background, there is what we call the Meteorite Vault. And so as a special treat to you, the audience of the Virtual Night Sky, in 2 weeks, we'll meet Lawrence, and he's going to take us into the vault and give us a really wonderful vault tour. And so we'll learn more about meteorites and how we find them and how we catalog them and all of that stuff. That would be super cool. And then 2 weeks after that, at our Wednesday meeting, and I think if I have my numbers right, that's going to be July the 12th. Or July the 13th is our program. It is Wednesday night. It is the day after the James Webb Space Telescope is supposed to be releasing their new images. And so the telescope, as you remember, we've talked about it a lot on the program because ASU has some time and some expertise basically helping with the telescope. We actually are learning that it completely deployed. It is in the right location. All of the alignments happened correctly. Everything it came together very, very in this complicated mission came together very, very well. And we will get our first science images on the day before our July meeting. So that's really super nice. Kim and I are also now conspiring to perhaps don't have the final details left, but we think we want to do the last of the July meetings, our Wednesday, July 27th, if I have the number right. We want to do it actually from the historic Lowell Observatory up in Flagstaff. So we've never tried this before, but what we'd like to do is actually broadcast from Flagstaff, from Lowell. You get the idea. We want to get out of the heat as much as anybody, but we're going to learn a little bit about that observatory, about astronomy in Arizona in general, and we'll have some other guests to talk about some of the history of that particular part of the state. So lots of really cool things happening. We've got them in program. I really appreciate your audience, your loyalty. I love that you join us every week, and I hope we just bring something topical and something interesting for you to think about every time we meet. So with that, it is very, very close to the appointed hour. I'm going to say thank you very much for attending tonight, and we will see you in 2 weeks. Thank you very much.